Today we are going to discuss about wireless telecommunication technologies and its generations. So it is starting from 0G, then comes first generation, second generation, third generation, 4G, 5G, and now the research on 6G is going on. 0G, that is in 1940s, that is referred to as pre-cellular systems, or sometimes zero generation, that is 0G mobile. In zero generation, there were no wireless telecommunications. That is a starting stage of communication technologies, that is traditional analog telephone services. Then, after a long gap, in 1979, 1G is introduced. 1G or first generation, that is refers to first generation of wireless telephone technology or mobile telecommunications. These are the analog communication standard that were introduced in 1979 and the early to mid 1980s and continued until being replaced by 2G digital telecommunications. The main difference between these two mobile telephone generation is that in first generation systems, the audio was encoded as analog radio signals, while 2G networks were entirely digital. In 1991, 2G services introduced. 2G provides three primary benefits over the predecessors 1G and 0G. First one, phone conversations are digitally encrypted. Next, 2G systems are significantly more efficient on the spectrum, allowing for far greater mobile phone penetration levels. And the third benefit is 2G introduced data services for mobile, starting with SMS, that is short message service, plain text based messages. Before the launch of 3G services, in between 2G and 3G, there is a 2.5G. 2.5G denotes 2G systems that have implemented a packet switched domain in addition to circuit switched domain. It does not necessarily provide faster service because bundling of time slots is used for circuit switched data services or HSCSD as well, also called General Packet Radio Service or Gprs. When we discuss about 3G technology provides an information transfer rate of at least 144 kbps. Later 3G releases, often denoted 3.5G and 3.75G, also provide mobile broadband access of several megabits per second to smartphones and mobile modems in laptop computers. This ensures that it can be applied to wireless voice telephony, mobile internet access, fixed wireless internet access, video calls, and mobile TV technologies. Before introducing 4G in 2009, there is a 3.5G or generation. 3.5G is a grouping of disparate mobile telephony and data technology designed to provide better performance than 3G systems as an interim step towards the deployment of full 4G capacity. The technology includes high-speed downlink packet access or HSDPA. From there, an evolved HSPA technology is also used, and after that, before 4G, there comes 3.75G. So that is evolved high-speed packet access or HSPA plus or HSPA. HSPAP is a technical standard for wireless broadband telecommunication. It is the second phase of high-speed packet access or HSPA. Then comes 4G in 2009. 4G provides, in addition to the usual voice and other services of 3G, mobile broadband internet access, for example, to laptop with wireless modems, to smartphones, and to other mobile devices. Potential and current applications include amended mobile web access, IP telephony, gaming services, high definition mobile TV, video conferencing, 3D television, and cloud computing, etc. LTE or long time evolution is commonly marketed as 4G LTE, but it did not initially meet the technical criteria of a 3G wireless services as specified in the 3GPP release 8 and 9 document series for LTE Advanced. And in 2020, in many of the developed countries, 5G services are introduced. We will look into the generations of telephone communication, mobile telephone communication, or cellular communication technologies in detail. So, here a summary of mobile technology is specified in this diagram, that is starting from 1990 till date. So, many of the technologies specified here are discussed already. So, starting from GSM in late 1990s, then comes our second generation after 1G in using GSM. Second generation comes with Gprs services, then comes Edge services, Umts, HSPA, LTE, etc. So we will discuss all the technologies along with the generations of mobile communication. First generation. In the first generation system, the available frequency spectrum was split into a number of sub-bands or channels, each of which was used by a different caller. So here many sub-bands are given. There is 1G frequency band split into 5 different sub-channels. 1G standards used in different countries. In USA, it is AMPS, that is Advanced Mobile Phone System. In various European countries, it is NMT 450, that is Nordic Mobile Telephone. NMT stands for Nordic Mobile Telephone, that is a standard used in European countries. And in the United Kingdom, TACS or Total Access Communication System, that is the different standards used by different continents and countries. 1G technology was also called FDMA, that is Frequency Division Multiple Access. In 1G, if a caller hanged up, another caller could use the same frequency. When a caller crossed a cell boundary, the channel being used might not be made available in the new cell, as it might already be in use with some other user. During a handoff, a different channel was possible to be allocated in first generation, otherwise the call got dropped if none were available. Being analog transmission, the voice quality was poor. Also, it provided no security since anyone could hear a call by tuning into a channel or tuning into that particular specified frequency. These are some of the advantages and disadvantages in the era of first generation. Then comes second generation of mobile communication. There were many disadvantages. The smaller number of simultaneous cells or calls, high risk of call drops during handoff. Call in 1G were expensive because of inherent inefficient usage of bandwidth spectrum, and hence very few could afford to use a cell phone, not capable of providing services such as SMS, caller identity, etc. So these disadvantages of 1G system were overcome by the second generation cellular system. So these are the first generation technologies problems. So for overcoming all these problems, 2G services are introduced. 2G refers to second generation of mobile networks based on GSM. The radio signals used by 1G network were analog, while 2G networks were digital. 2G capabilities were achieved by allowing multiple users on a single channel through multiplexing. During second generation, cellular phones were used for data along with voice. Some of the key features of 2G were data speed of up to 64 kbps, use of digital signals instead of analog, then enabled services such as SMS and MMS or multimedia message services are there, provided better quality of voice. It used a bandwidth of 30 to 200 kilohertz. Here in 2G, the systems encoded voice and other information digitally before transmitting them. Digital transmission include noise immunity and better bandwidth utilization. 2G replaces 1G because of the drastic reductions in the cost of phone calls and availability of a wider range of services coupled with substantial improvements in the quality of services. SMS became possible. Also, some of the service providers were given the capability for MMS or multimedia message services. Here, some similarities and differences between 1G and 2G are specified here. Similarities are 1G and 2G use the same cell structure. There are many differences. 1G and 2G uses different signal modulation techniques. 2G uses CDMA and TDMA as channel access technology, while 1G used FDMA, that is frequency division multiple access. 2G uses chord division multiple access and time division multiple access as channel access technology. 2G mobile system deployment started in 1990s. The standards used were in North America, IS-95 standard was adopted, which used CDMA and could multiplex up to 64 calls per channel in the 800 MHz band. In Europe and elsewhere, operators adopted GSM standard including India, which uses TDMA to multiplex up to 8 calls per channel in the 900 to 1800 MHz bands. The first commercial deployment of GSM was done in 1992. It supported higher voice quality and provided data service such as SMS and email. In 1993, another 2G system known as CDMA-1 was standardized and commercially deployed in South Korea and Hong Kong in 1995, followed by USA in 1996. Before the deployment of 3G, there is a generation that is 2.5G, or in between second generation and third generation, there is 2.5 generation. The technology Gprs or General Packet Radio Service is an extension of GSM and is considered to be the 2.5 generation technology. It is based on packet switching compared to circuit switching used in second generation mobile telecommunication. GPRS allows users to remain connected to the internet without incurring additional charge and supports multimedia capabilities including graphical and video communication. GPRS deployments began in 2000, followed by Edge technology, that is enhanced data for global evolution. Edge technology enhances the capability of GPRS, allows faster internet browsing and makes it possible to use streaming applications. Though this technology provided faster data rates over 2G system, it is called 2.5G because it did not offer the multi-megabit data rates which are the characteristics of the 3G system. And here, third generation mobile telecommunication. The 3G standard utilizes Universal Mobile Telecommunication System or UMTS as its core network architecture. 3G network combines aspects of 2G network with new technologies and protocols to deliver a significantly faster data rate. By using packet switching, the original technology was improved to allow speeds of up to 14 megabits per second. It used wideband wireless network that increased clarity. The 3G systems are often referred to as IMT 2000, that is International Telecommunications 2000 or 2000 system, since this was made a global standard by ITU. 3G systems support much higher data transmission rate and offer increased bandwidth, makes them suitable for higher speed data and high quality voice calls. 3G is a pure data network. Since voice signals are converted to digital data, 3G uses packet switching technology. 3G uses somewhat different infrastructure compared to 2G and so offer many innovative applications and services like email, instant messaging, video telephony, multimedia gaming, live video buffering, location based services, etc. The first 3G network was deployed in Japan in 2001 by Docomo. The technology introduced in third generation is UMTS, Universal Mobile Telephone System, is one of the 3G mobile systems that was developed within the ITU's IMD 2000 framework. UMTS was developed mainly for GSM networks so that this could be easily upgraded to UMTS network. In UMTS, coverage is provided by a combination of variety of cell sizes ranging from in-building picocells to global cells provided by satellites. The main 3G technologies that are prevalent include UMTS and CDMA 2000. European countries have adopted UMTS and USA uses CDMA 2000. It operates at a range of 2100 MHz and has a bandwidth of 15 to 20 MHz. Some of the main features of 3G are speed of up to 2 Mbps, increased bandwidth and data transfer rate, send or receive large email messages, large capacities and broadband capabilities. And in fourth generation, the main difference between 3G and 4G is the data rate. There is also a huge difference between 3G and 4G technology. The key technologies that have made 4G possible are MIMO, that is multiple input, multiple output, and OFDM, that is orthogonal frequency division multiplexing. The most important 4G standards are WiMAX and LTE. While 4G LTE is a major improvement over 3G speeds, it is technically not 4G. What is the difference between 4G and LTE that we will see later? A 4G system provides at least 10 times faster data rate than that of 3G and makes mobile broadband internet possible. 4G systems has made possible high-speed internet access from smartphones and laptops with USB wireless modem. New applications made possible through 4G, that is IP telephony, gaming services, HD mobile TV, video conferencing, and 3D television. There are two competing 4G standards, WiMAX and LTE. 4G LTE. LTE stands for Long Term Evolution. This is a next generation mobile broadband technology, and that is what we are enjoying now. It promises a data transfer rate of 100 Mbps based on UMTS 3G technology, and that is advanced technology when we compare with UMTS 3G, that provides 10 times more bandwidth than the 3G, any of the 3G technologies, and it is optimized for all IP traffic. Here describes some of the advantages of LTE. High network throughput, low latency, plug and play architecture is provided by LTE services. It is having low operating cost. All IP network traffic is supported. Simplified upgrade path from 3G networks to a 4G LTE, faster data downloads and uploads, improved response for applications, and improved end user experience. So these are some of the advantages of LTE service. Even after it was widely available, many networks were not up to the required speed of 4G. 4G LTE is a fourth generation long-term evolution capable of delivering a very fast and secure internet connection. Basically, 4G is predetermined standard for mobile network connections. 4G LTE is the term given to the path which has to be followed to achieve those predefined standards. Some of the features of 4G LTE are support interactive multimedia voice and video, high speed, high capacity and low cost per bit data transfer rate, that is speeds of up to 20 megabits or more. Global and scalable mobile networks, ad hoc and multi-hop networks are supported by 4G. In between 3G and 4G, there is an era of 3.5G, that is by using a technology known as HSPA, that is high speed packet access. There are two different packet access, one is for downlink and one is for uplink. So those technologies are named high speed downlink packet access or HSDPA, and for uplink HSUPA, that is high speed uplink packet access. So this extends and improves the performance of existing wireless CDMA protocols. 3.5G introduces many new features that will enhance the UMTS technology in future. So EVDV already supports most of the features that will be provided in 3.5G. These include adaptive modulation and coding, fast scheduling, backward compatibility with 3G, enhanced air interference. So this is the comparison of LTE speed with all other generation technologies. In 2G, 14.4 kbps was the data rate or bandwidth. 2.5G, 384 kbps. 3G, 14.4 mbps. LTE supports 115 mbps and 4G 1 gbps. So this is a comparison of LTE speed. Some of the radio technologies supported by LTE uses orthogonal frequency division multiplexing or OFDM for downlink, use single carrier frequency division multiple access SCFDMA for uplink, use multi-input multi-output or MIMO for enhanced throughput, reduced power consumption, higher RF power amplifier efficiency, so less battery power used by handsets. So these are some of the LTE radio technology and its advantages. So this is the LTE architecture. Just have a look at this particular diagram. In as per our syllabus, there is it is not required to study the LTE architecture. Thank you.